Hey everybody, and welcome back to the channel. Um, we're going to start doing a small preview of what we did during the last video. So we'll go ahead and do that. All we've done is basically initialize Direct3D and create two windows with two window loops. As the first window closes, if the return result is 0, then a new window pops up and then that one closes and the application ends. The first window will be the selection window and the second window will be the actual help desk window. I have been sick. And again, I'm working basically 3 jobs, so just bear with me. I'm going to pump these videos out, but I know that they're not coming out weekly like they were for the first few videos. It's just I've been extremely busy, and like this week, I was going to pump one out Monday, but I've just been sick, so I decided to wait till Wednesday. I'm no better, so screw it. Here we are. Let's go ahead and get right into it. So in the last video, we initialized a Direct 3D render context, which is basically the context for rendering with DirectX 11. And so we'll go ahead and go to that file. And all we have is a device and a device context. Now what we need is we need a swap chain as well as a render target view so we can clear it and get like a blue color going to the window. So we'll start with that. So one thing that we're going to need in the window is we're going to need access to our actual window handle, which is here. And the easiest way to do that is just to make a public member and just call get handle. And we'll simply return the handle. I'm going to try to get the microphone out from the keyboard. Okay, so now we have a way to get the handle. The next thing we're going to need is we're going to need some sort of a swap chainable thing. So two ways to do this. The first way is we could make it its own object. So we could do like a window render target, and that would include a swap chain along with a Direct3D render target. Or we could program it directly into the window class. The window class would make it less code, but also less portable. So for instance, if we decided later to swap out and use an OpenGL render context, the window class would be directly tied to Direct3D. So I think the better way to do this would be to actually rely on the upper class windows to handle Direct3D and let the actual window just deal with operating system specific stuff like it already is. So we'll create a new module, and we're going to call it D3D11 render target. Let's call this D3D11 window render target. So it's kind of specific. I know it's a long name, but it will be specific what it is for. And like last time, we need to include our precompiled header here, and we need to finish our module declaration. So this is D3D11 window render target. Go ahead and put this inside of our namespace and create export class D3D11 window render target. Okay, and now we included the com pointer I think it was the last video, the video before that. So we included all the DirectX stuff. So what we need for this to work is we need a swap chain, which is just its usage is going to be render target view. And then we need a D3D11 texture 2D, call it the back buffer, which is what it will be from the render target, or from the swap chain. And then we need a render target view. So now we're going to do IDXGI swap chain pointer, get swap chain. We need a getter for our back buffer. Oh my god, I have a headache, so my brain's not working correctly. And we need a way to get our render target view. We're also going to go ahead and add one function for whenever a window is resized, and it's going to take 0 parameters. We could take in a width and a height, but we're going to let DXGI handle this for us, specifically because we don't need that extra nanosecond of speed for what we're doing. And again, it's only going to happen when the window's resized, so there's already a penalty anyway. So I'm not too worried about letting DXGI calculate the size. And then the last thing that we need a constructor that's going to take in a window. So we'll go ahead and import window. Remote desk window. Take it in by reference. And we don't need to keep a copy of the window. All we need to do is go ahead and set up with the window handle to DXGI. So we'll go ahead and do that here. And then we'll go ahead and get the client rectangle too, because I know that we'll need both of these things. And then we'll simply make a client width. And we have to static cast this because everything in the rect is along. And just subtract the right from the left. And then we're going to do the same thing for the client height. Except this time we subtract the bottom from the top. Okay, and so this gives us pretty much everything that we need in order to start. But we also need a first off, this can be const because we're not modifying the window. And we're also going to do const here, and we're going to simply import the 3D11 render context. And we can just make this equal get D3D11 render context by default. And of course, this is pointer. So now we have a good default to get the render context if one doesn't already exist. But for performance, you pass in your own render context and you're just simply passing in the location. It's not having to check its value. So this again is one of the optional things where it's like I need to know about the render context. But if you do not provide me with one, I'm simply going to say, okay, I keep highlighting the code again. I'm going to go ahead and apologize for this in advance, just like an ADHD thing. I don't know what it is. So I'm going to stop doing that. But so the only problem here is you could, in theory, pass a null pointer here. And that is a problem. If you give me no pointer for this, I need the render context. So we need to throw an exception of invalid argument if render context is null. So if render context is null pointer, throw an invalid argument. Render context must not be null. And we'll make it punctually correct. And I forgot C++. Again, I'm coming from different languages. I haven't written C++ since the last video, so just forgive me if something looks a little wonky. Okay, so what's next? we don't have to validate the window because it's by reference. We need to cache our render context. So we'll go ahead and put one of these here, ID, well, D3D11 render context. And we're going to go ahead and default initialize all of these. And this one here will default initialize to null pointer. And we'll simply capture M render context is render context, like this. Oh, and I need to add the const annotation here, which is completely fine because we're not physically modifying it. We're using it to read values. All right, so now we have a way to get a windowed render target. You give me a window and then a render context optionally. But if you want to speed things up, you hand me the render context and I just do the right thing. Okay, so I'm also thinking like if it is null, right? I could just simply create null, but that defeats the purpose of this. So we're not going to do that. If you give me null pointer, I'm going to throw an exception. If you want to use the default, don't pass an argument. Okay, so now we have our window handle, the client rectangle, and this is the client width and height. What we need to do first, before we do anything here, we need to get a DXGI device. And we'll get this from our render context. So we could, I think I'm going to create a function in the render context instead of here to get the factory because it may be used in more than one place. Like for instance, if we need to enumerate outputs, it doesn't make sense to rewrite the same code twice, and we get the advantage of not having to wrap anything in a com pointer. So we're going to come back here, and I'm going to com pointer IDXGI factory, get DXGI factory, and actually I'm going to change this from get to query. And this is not const. Okay, so we're going to start here. We're going to use the com pointer class, so now we can just use com pointer like this. And we need to start out with a device. So now that we have a device, we can simply do an H result, and we can detect whether or not we successfully have queried the DXGI device from the Direct3D device. And the way that we do this is with a method called query interface on the device. So if we were to do md3d11 device query interface, we could just use the IID, or the way to get that is underscore underscore. I'll go ahead and show you. UUID of and then IDXGI device, and then you simply pass in the actual device, and this gets it. This returns an H result in case anything goes wrong. But there's an even easier way to do that, and you'll never have to use this except for I think in one place. No, there's actually two ways. So another shortcut is to use a macro IID PPV args, and then pass in the DXGI device like this. So this is the second way to call query interface, and this works too. Just a little bit shorter, and if you see this macro, that's basically what that's doing. It's getting the UUID of whatever you're passing in. So it's kind of smart, and it knows how to calculate what you're passing in, what the type is, and then it just simply makes that a void pointer. But there's an even easier way. Since these are already COM pointer types, the easiest way to do this is to use the device and then use a function called as, and then pass in my device. This is shorter, it's more readable, it makes sense, and this is safe because this is designed to work with COM pointers. So there's no need to have to worry about reference counting or anything like that. You don't have to with the other two methods. But this works natively with COM pointer, and there are a couple instances where you should not query interface, and as kind of protects you in those instances. So I'm going to use as a replacement for query interface anytime I need to do that. And now we're going to simply check if failed will throw a runtime error. Failed to query DXGI, and again, be grammatically correct. Okay, and so that's querying the DXGI device. The next thing we need is we need the DXGI adapter. And so what is the device and what is the adapter? The device is basically the lowest level of a resource creation mechanism in DirectX. And the adapter is basically communication with the hardware. So you can think of an adapter as an actual graphics card and a device as a reference to like creation tables for that device. Okay, that's not exactly what's going on, but it's the easiest way to think about it. And so I have this adapter, which again we just said is basically the graphics card, and we want to get whatever graphics card the system used automatically. And since we went from a Direct 3D device to a DXGI device, we simply tell the DXGI device, give me the adapter that you are set to. So we'll go ahead and create our DXGI adapter, and we'll do DXGI device get adapter like this. DXGI adapter, and that's it. And then you just simply check if failed HR throw runtime error, failed to get DXGI adapter from DXGI device. This way we can be kind of specific in what the error is. And the last thing we need finally is the DXGI factory. And this is a little bit different and a little bit weird, and there's only one way to do this. You can't use as. What you need to do is you need to call the get parent method of the device and then use the UUID trick or the IID underscore PPV args. And that's how I'm going to do it because it's the easiest way to do it. You don't have to worry about messing up the UUID or anything. So we have our DXGI adapter. We call the get parent method. We use IID PPV args and then pass in our factory. If this fails, we'll simply throw a runtime error. Failed to get the DXGI factory from the DXGI adapter. And last but not least, we're going to return the DXGI factory. And here we have to pay a copy, but what's cool is if it doesn't do it now, it will in the future. Eventually, RVO will optimize this where it's not a copy, it'll be a move. But if it is a copy, it's not a huge performance penalty anyway because you're probably querying the DXGI factory during setup. So I'm not worried about performance in this, and not in the slightest bit. I think this is going to be completely fine for what we need, especially when it comes to creating resources. And this is how we get our DXGI factory. Okay, so now it's time to actually test. So we need to go back to our render target, and we have our render context already. So what we need is we're just going to do auto DXGI factory equals M render context. Oh, that's right, it's const. This is not modifying anything, I do not think. But as, oh, see, yeah, nope, okay, no, that's fine, that's const. Perfect. So it equals the render context, query the factory. And that's it. Now we have this com pointer type of IDXGI factory. And now we can use this to create a swap chain, the back buffer, and the render target view. And this is how that's done. The first thing we're going to need is we're going to need some properties. So we have a window handle, we have the client rectangle, and the client width and height of the current window. We need a DXGI swap chain descriptor. And again, I understand that there are better ones to use than standard DXGI, but this, for our purposes, is going to be completely fine. If for any reason this doesn't compile, I'll have to switch it up and use the other methods or the other factory types, but I think this will be fine. We'll start with the buffer count. We'll just make it 2. Now we need to fill out our descriptor. The width is the client width, if I can spell. The height is going to be the client's height. The refresh rate is going to be, I'm just going to do 60/1, but again, we're not going into full screen, so this doesn't even matter anyway. We need a format, DXGI format, R8, and we'll use the standard one, which is the 8-bit. Where are you at? It's this one, but instead of uint, it's u normalized. And what this means basically is there's a red, green, blue, and alpha channel. That's 4 channels. Each is 8-bit, and it's a uniform or unsigned normalized value. So what this means is it's a value between 0 and 1. And you can see why we do this later when we start making shaders and stuff. But the whole reason that we use this value as like the default is because the values going directly into the shader are the same as they are in C++. So you are literally writing like 0.05, and that gives you 5%. So if you're doing something on a red color and you pass in 1, that's 100% red. If you pass in 0.5, it's 50% red, so on and so forth. So there's a consistency between what's going on in the shader and what's going on the C++ end. This is the reason we're using this. We're also not dealing with HDR or any of the more sophisticated monitor setup stuff. So we're not worried about that in our application. So we don't need to handle HDR or we don't even need to handle VSync for real. I'm going to turn VSync on specifically to keep everything running smoothly, but you don't even really have to worry about VSync or screen tearing for real if you're making an application like this. But we are going to eventually allow tearing, and we're going to be using VSync. So, but that's more sophisticated stuff. We'll get into that stuff later. So we're going to set it to windowed. We need a default symbol descriptor, and 1 and 0 basically sets the values in the struct. I think it's the count to 1 and the quality to 0, and this is default state, basically stating we're not using any multi-sampling. And we need, let's see, output window is going to be the window handle. And we don't need flags, but we do need a usage. And this is going to be usage of render target output, and this allows us to create a back buffer and use that buffer as a render target view. So now we're going to create an H result, and we're going to use our DXGI factory to create the swap chain. And this is pretty easy. You just simply use our render context get D3D11 device. This is the swap chain descriptor, and this is the actual swap chain. So and if it fails, we'll simply throw a runtime error failed to create swap chain. So now that we have that, now we can get the back buffer of the swap chain. And to do that, you just call the swap chains method get buffer. We're getting buffer 0, and you use the IID macro again and pass in our back buffer. That's that. And if this fails, throw a runtime error. Failed to get back buffer from swap chain. And now we're going to use our actual render context. We're going to get the device, and we're going to use that device to create a render target view from the back buffer. So our back buffer is back buffer get. We don't need a descriptor, and the reason we don't need a descriptor is because it's literally a two-dimensional buffer, and that's the default state anyway. But if you needed multi-dimensional 2D sheets, like sprite sheets and things like that, you would want to create a render target view descriptor to tell the pipeline exactly how and on what stage to render two specific render targets, or to what depth of the buffer. So like if it's a three-dimensional buffer, you have multiple sheets of two-dimensional textures. Anyway, that's sophisticated stuff. We won't get into that right now. We're just going to stick with the basics. And we need to pass in our render target view. If this fails, then we're going to throw a runtime error. Failed to create render target view from back buffer. And that's it. Although you are about to see that we are about to have to rewrite this code here. So I'm going to move this code into a different function. Void create a buffer and view. And that's it. I'd added the H result there to make it easier, but this is all you have to do. And then here, we'll get rid of these two, and we will call this create buffer and view. And if that throws an exception, it trickles up, so on and so forth. And then on window resize, we need to simply reset our back buffer and our render target. So back buffer reset, and that's going to clear it. Render target view reset. M swap chain resize buffers 000 DXGI format unknown 0. This is the easiest function call in the world, because this is going to tell DXGI just keep the existing stats and find the client width and height for me. And last but not least, this create buffer and view. And that's it. So when the window gets resized, we need to reset the back buffer and the render target, and then we need to basically resize the buffers of the swap chain. Now this function here gets called. It's important that you unbind whatever render target is already bound to the pipeline. You need to unbind it yourself, and we'll kind of get into why that is. But you could end up with duplicate code, or you could have another render target bound, and then you'd have to do a check. And then if it's the current render target, then you unbind it. So there are a couple different ways to do this, but now you're going back into reference counting mechanisms, and this is the easiest way to do it. And just physically on the pipeline, when the window gets resized, just go ahead globally and unbind any sort of renderable thing, something that is device but also like the client width resource dependent. If anything has to be recreated, you need to unbind it from the pipeline. That is the rule of thumb, and we're going to do that in the higher level windows. And we might even create a class to do it for us, but for now this is fine. And then we want one more function. We want a present function, and you went vsync, and I'm just going to set that to 0. And we're going to take the swap chain. We're going to present with our sync interval and no flags. This is it. There's nothing else to this. Now, of course, we could have this return an H result and just simply return that. I think we're good to go. So now it's time to actually test. So to test, what we're going to do is we're going to go back to the when_main function. And we have our context here, and we have a selection window. So now we need to, I'm going to import the window render target. And we're going to do D3 remote desk D3D11 window render target. We need to pass in a window by reference and then pass in our context. And that should give us a render target that we can now render to. Now we need to restructure our loop here. So in order to do this, what we need to do is we need to basically do peak message instead of get message. So we have our message, and then while message.message does not equal wm quit, if we peak message, we'll just remove it from the queue and we'll process it immediately. There are better ways to do this, but for our case, I think this is fine. We need to translate the message and then dispatch the message, and I don't know what display burst is. And then we do an else statement, and then here we simply do our render target. And we need to either, okay, so we need to call present. And for right now, we're going to see what happens, because it should be black, because we haven't cleared it or anything, so it should be everything defaulted to like 0. But if something doesn't compile or run right, oh, we have an exception. So DXGI factory. You know, I get this error a lot, actually, and I'm not exactly sure. But I know that this is the right logic. Let me see. When I'm creating the render context, how am I creating it? I'm creating a hardware device, default device. Huh. Okay, yeah. This is weird because this should work. I'm gonna try to create a breakpoint, but it might not break. Yep, I was worried about that. So it looks like it's throwing here on get parent. No such interface supported. I knew this was going to happen because see, we have an adapter, we have a device, but DXGI factory by default is not supported, and I think it's because we're on Windows 11. So we need to, I'm assuming, get like DXGI factory 1 or something. Let's try that. Let's see if DXGI factory 1 exists. No such interface. DXGI factory 5. We're just going to keep going until we get something that works. This is so weird. I get this error sometimes, and it doesn't make sense to me because it has no problem getting the device and the adapter. So, you know what we're gonna do? We're gonna go to DXGI factory from DXGI device. I'm all over the place here. Let me. Yeah, right here. Create a factory by calling create factory. Because you can create a Direct3D device without creating a swap chain, you might need to retrieve the factory that is used to create the device in order to create a swap chain. You can request the device interface from the Direct3D device and then use the object getParent method to locate the factory. The following code shows how. We have a device. We query the interface for that device, so that's working. We get the adapter, that's working. And then we call getParent on the adapter to get the factory. I am so confused why this is not working. And it's clear as day that we are supporting feature level 11. So, like, if I come here, that's right, breakpoints don't work in modules. um, it says no such interface is supported. Oh, you know what? Let's go to the project properties. Let's go to the linker. Let's go to the input. And let's do dxgi.lib. Not sure if that has anything to do with it, but we're going to try that. Nope. Huh. This is so weird because I'm getting an adapter and everything else. Like, why is it doing this? Oh, I know exactly why. It's because I think we're feature level 11.1. Let me check. Because I need to do D3D11 create device. I think this can possibly create like a Direct3D 12 device, and it's not supported. So what we need to do physically is we need to set our feature level here to D3D11 or D3D feature level 11. So we're going to try this. This is the only change that we're doing. Our feature levels array is basically just the address of this, and we got 1. Now watch. I'm really going to be concerned that this doesn't work. If it's less than or equal to. No, it should be less than. Okay. Feature level is 0. This is so weird. I wish I could see the actual system error. Invalid arg. Oh, my dumbass. D3D feature level. Requested feature levels. D3D feature level 11. Yeah, we'll keep this one zeroed out so we can still check it. And we'll do our requested feature levels, and we'll do an ugly macro for array size, requested feature levels. So now it should create the device without a problem, and it does, and now we're back to square one. It's so frustrating, man. Because there's always a problem with some of these. No interface. No interface. Let's do like, what's the latest? What's the latest DXGI? What, let's do 1_5, and it's factory 5. Well, that should have worked. Hold on. Maybe there's a bug report or something, because this 100% should work. Windows 11 adapter, get parent, or DXGI factory, E, no interface. Maybe someone else has a solution. So factory 1, device, adapter get parent. Yeah, I just did all that. For DirectX 12, these DXGI backtrack conversions, such as code above, are explicitly not supported. You are expected to create the factory directly. Now, I know for a fact my PC supports Direct3D 11. I don't care about all that. Hold on, I'm going to pause this. Okay, can confirm Direct3D 11 is supported on my system, so I don't know why this is giving me problems. In some cases in DXGI where you can navigate back via query interface and get parent, for example, the following code is good, consistent way to get back to the factory from the Direct3D 11 device. Yeah, you take the device as DXGI device, adapter, and adapter get parent DXGI factory. While this works in simple cases like the ones above, generally type shifting is often problematic and or buggy. For example, the Direct3D 11, there were problems if you use create factory method instead of create factory 1, or if you mixed both in the same process. As such, for DirectX 12, these DXGI backtrack conversions are not there. Basically, that's yeah. This is so weird. I don't know. I've done this 1,000 times in code, and I've never had this problem. I know it's been deprecated. I don't care. Okay, yep. All right, we're gonna go. We're gonna go the other way. And unfortunately, this is the only way I know how to do this. So we're going to first. Let's go back to our precompiled header. We're gonna have to go up a little ways. We're gonna have to use Direct3D 11.1 or 11.1, DXGI 1_5. Okay, and the GI 1_5, and this should show me the interfaces that are supported. So device 4. Okay, so device 4. Then we got to go back. Well, we're in our render context, and we need to change this to 11.1 and this to 11.1. But honestly, that should fail anyway. But I'm still doing the check, so I don't have to change the code. Okay, so now we have that device. We're going to call get adapter on it, and then we're going to query the interface, which basically allows us to get up the adapter chain. It's going to be adapter 3. Yeah, let me just make sure this works. We're going to throw a runtime error. Failed to query DXGI adapter 3 from DXGI adapter. I don't even know why I'm writing this because it's not doing what oh, I know exactly what's going on. I need to like dump it. I'm in debug mode, so it's not going to show me the actual exceptions. Although I wish it would. I wish it would do this, but it's not going to. So screw it. We'll just go on with this. And now we need a factory 5. We're going to call our adapter 3 get parent adapter 5. And here we're going to return an adapter 5. So this makes things a little more complicated on our render target side because create swap chains no longer supported. So now we have to do something else. And so now we have this factory 5 interface, and we have to call create swap chain for handle window. We still need our device, so m render context get device. We need a handle to the window, so window handle. We need swap chain descriptor 1, so we'll go ahead and create that. We need a full screen descriptor. Can I pass null pointer in there because we're not going full screen? I know restrict the output can be null pointer. And then we need a DXGI swap chain 1, and we'll do the same thing here. So now we're going to get our new and improved swap chain. Alpha mode doesn't matter. Buffer counts 2. Buffer usage, DXGI usage, render target output. Format, DXGI format, same thing. Green, blue 8, alpha 8. Unsigned normalized. Sample descriptor 1, 0. I wish they had the helper classes for these, but they don't. Width, client width. Height, client height. Alpha mode doesn't matter to us. Scaling doesn't matter to us. Stereo we're not using. Swap effect. Swap effect. Flip this card. I think it's Windows 10 and above. Yeah, because discard I think is not supported. If you use discard here with this type of swap chain, I think it'll fail to create. So let's try this. Let's just see what happens. And if this doesn't work, I'm going to have to pause the video and do some research. But I'm hoping this just compiles. And we're in the same problem. I do not know what's going on. This should not be happening right now because, I mean, we're able to get all the way up to the adapter. And then whenever we call get parent, it's not working. All right, I'm going to pause the video and do some research. I'll be back. Okay, so I'm going to attempt. I don't have video editing software, so I don't really know how to stitch two videos together at the moment. but I have a feeling that it's another piece of software interfering. Because what I've done is I've just, after I create the device, I'm also using Direct3D 11.1. So I'm using device 1 and device context 1 and factory 5. So I know my operating system support these. So much so that I have an identical device. I just took the code, I copy and pasted this exact module exactly as it is, and I did not get an exception. I also added debug, and there's no debug information. So the only thing that's different between this system and the other system that I just tried it on and it worked on the other system is OBS was running to record. So I'm going to, I guess, drop OBS for a minute and just see if I can get it to run on this machine. And if not, maybe a driver's out of date. I don't even know why I didn't check that. But either way, it's gonna cancel the video. So I'm gonna stop the video here. So OBS is going to exit, and I'm probably going to upload another part along with this video, just to, because I don't know how to stitch them together yet. It's probably not that hard. So you know what? I'll figure it out and we'll do it then. So you're seeing me screw up live, and I'm trying to figure out what's going on. But again, honestly, the only difference between this code and the the code on the other machine, but I scratch that. There is no difference between the code. It's an exact copy paste. I sent it through Messenger, and then I just copied it on to the new machine on Visual Studio, and it just worked. So I don't know what's going on here. And again, identical machines. They're both Alienwares. They both have really good GPUs. I don't know what's going on here, but I'm gonna cancel OBS, and we're gonna see if that helps. So I'll be back. Okay, I just kind of want to go over something real quick. I still haven't figured out exactly what's going on, but I just copy and pasted the code. I made a single line change. There was a bug where I wasn't capturing the render context's DXGI factory, but the exception was still being thrown here, so it doesn't matter anyway. But if we come down, guess what? I have a factory. I just copy and pasted the code. There is nothing else that I've not done anything else. The code's exactly the same. So that means that there is a problem in my first application. So we are going to reopen that. Go ahead and make the one change that I did find. And then we'll figure out exactly what's going on from there. Where are you at? So again, the only thing I changed in the original code was this. And we're going to get MDXGI factory. Everything else exactly the same, but it's still going to fail. And the only thing that I can think is it's possible somehow it's in win main, and that's what's screwing it up. So I'm getting this render context here after I create the window. But what if we were to, for instance, create the render context and then create the window? Let's just see what would happen. It comes out with the exact same thing. So it's gotta be like a build priority issue, but I don't know exactly what it is. I also included the same header, so I included D3D 11.1 and DXGI 1.5. I really do not know what's going on, unless I'm gonna try something else again. You know what? This is not going to compile because of WinSock, and these include Windows.h. And you know what? I think I just found my problem. Comment this out. Nope, same thing. So that's not the problem. Okay. I hate because I also cannot debug correctly. And it would take me forever to merge all the modules into CPP files because you also have to break them up into header files. This is going to be a pain, so just bear with me a minute. I'm going to try to work something else out. But you saw it worked when I copy and pasted the exact same code, the exact same class, the exact same code somewhere else. It just worked without a problem. But there's something specific about the render context in this context. It's just not working for whatever reason, and I don't know. I for the life of me cannot figure out why. I think I can breakpoint in the CPP file and maybe step in and see what's going on. Okay, so zeroing those out, and now we're calling create direct 3D11 devices. Okay, so now H result is okay. And now we're casting our devices. These are both set, so that's good. DXGI device is good. Adapter is good. Now we get no interface. The lovely problems of Windows. And actually, I think it's more of a Visual Studio thing. Or maybe it's something I did. I don't know. Maybe I screwed up adding dependencies or something. D3D11 DXGI.lib. You know what? Although I'm not in 32-bit, but I think that is a problem. I just saw it twice. Maybe it fixed itself. Okay, yeah, so I have no idea. I'm going to try cleaning and then rebuilding. Maybe that's got something to do with it. Same thing. I don't, for the life of me, I cannot figure out what is going on. And it's driving me insane. It really is driving me insane because it should not be doing that. And it's also not the static thing either because I did the same thing in the other application. In the context here, yeah, it's definitely a pointer, so it's not copying anything. It's not doing anything weird. I'm just going to make it explicit. Because maybe the application is trying to create two different types, maybe? Nope. That's not it. Huh. I'm at a loss for words because everything worked fine until I was trying to get the factory, and now everything's broken. So, I'm probably gonna have to work on this and get this to work correctly. And again, for the life of me, I cannot figure out why it's not working. If I switch to release 64-bit, let's just see what happens. Do I get the same error? I'm probably not in C++20. All configurations, all platforms, C++20. And I think in the release build, WinSock2, 32.lib, D3D11.lib, DXGI.lib, D2D1.lib, and I think that's it. We'll go ahead and apply those. Try recompiling. Nope, iterator move. What in the hell is going on? It's like it just broke. Like I have no idea how to solve any of the problems that I just ran into. Luckily though, I can get it back to the state it was in. It's just annoying. It's annoying when everything works perfect and then you got this one problem and you can't sort it out. And I haven't used Direct3D in months, so it's hard for me to know exactly what's going on. The debug's not reporting anything accurately. You can see here all it's reporting is that an exception was thrown. Poco not found exception. What the hell is this? Like I don't even know what this is. Looks like it's loading all the DLLs right and all that kind of stuff. So I don't really know. I don't know what this is. Poco not found exception. And then this is our exception. Huh. So weird. Yeah, because see, I'm just gonna comment these out and just see what happens. Selection window created. Closes, closes, ends. Yeah, I don't know for the life of me what is going on. Like the rest of the application's working perfect, but this for some weird reason. I don't know. I mean, it's really baffling to me. I don't care if the iPhone's not connected. And again, I mean, you saw it work. Am I crazy? Like this exact code worked. The exact same code worked in the other process. And I'm wondering if maybe I should just I'm gonna try something weird. You're not supposed to have to do it this way, but I'm gonna try it. I mean, the only thing I can honestly think is maybe when SOC 2 is getting in the way. I guess another easy fix for this is to only include these in the ones that I need. So DirectX color is probably fine. I'm gonna try something weird now. We're gonna come to our render context, and we're just gonna include these. So now that works. And we're going to include these. Is this one of those weird bugs where it's not gonna work unless they're locally included? Nope. Still doesn't do it. And what was that weird warning? Yeah, the order's messed up. I thought so. So weird, man. Like, anyway, if any of you guys have any ideas, I'm gonna have to look into this. Probably a lot more because I cannot for the life of me get this damn thing to work. And now we run into a real software problem. And again, if we were using standard C++ classes, guarantee you we would not be having this problem. And you know what? Let's test it. So I'm going to take my render context class. And you know what I'm going to do? I'm going to move it to main. Let's see if it lets me do this. Get rid of these. And I'm going to get rid of the render context like that. And screw it, I'm going to get rid of this one too. Let's see if we can't get render context to work right first. Please don't complain about... Oh, it's because it's export. Oh, wait a second. Is it like external dependency? So it can't figure out it's the same process and that... I swear to... I swear. Oh, this is so annoying. Oh. Okay, so now it wants to work. So I figured out the problem. The problem is the modules. Oh my god. Okay, so we figured it out. You just look here, folks. Modules are not ready for production. I do not care what people say. This is why this is a fun experiment to work with modules. I literally, my drivers are already up to date. I literally completely reinstalled the latest driver to make sure there wasn't a firmware bug. I restarted my computer. I restarted OBS. I went into DXGI. I went to device manager, completely disabled the graphics card, went to integrated graphics, and then rebooted my computer with the graphics card turned off and then turned it back on. I've tried like 4 or 5 different things and none of it worked. But as soon as I took this out of a module, boom, it works. This is insane. So DirectX code cannot be put into modules. I do not care what anybody says. They're not ready to go into modules. But there is another cool little trick. Unrecoverable error. Oh, yeah, that's because the context is not there. So what we're going to do is we're going to see about this trick. Okay, now it's time to do something really weird. So forgive me, Father, for I have sinned. Let's do it. Now that we know exactly what the problem is, we can get the factory by other means, okay? So what we're going to do specifically is in the precompiled header. I know this is ugly, but I don't want to create a header and inline this specifically for this functionality. I'm just going to create an inline thing here. Namespace, remote desk. No, better yet, DirectX. Screw it. Let's do it this way. I'm not going to do that. That's cheap. Why are you not saving? Anyway, inline com pointer IDXGI factory 5. Get DXGI factory from DXGI adapter. And here I need an IDXGI adapter pointer DXGI adapter. And if DXGI adapter is no pointer, throw invalid argument. DXGI adapter must not be null. And factory 1, DXGI factory. No, and we're doing that weird shit again. There you go. Now we're going to have a H result, and we're going to do CI adapter. Get parent. Get the factory. And actually, I think this can just be a factory 5. We don't have to do the weird query interface thing. I don't even know why I was doing that. All right, small simple function, but hopefully this works. We'll come up here, and now instead of doing this, mdxgi factory equals get DXGI factory from adapter, and we're simply going to pass in our adapter.get. Done. All right. Now let's see if everything compiles, runs, etc., etc. So now we're back to where we were, creating a context, and then a selection window, and then a render target. And then we're going to try to render and present it. So come on, please just work. And again, I know this is weird to have to do something like that in line in the precompiled header, but I really don't know how else to do it. And it works. Like, this is so weird. Okay, so the create render target view failed, so. Oh. Let's do 2, because I forgot we're on Windows 10. 2 and flip sequential. Now let's see what happens. Okay, so back buffer is not valid. Swap chain is valid, so it is creating a swap chain. Um, let's try. Oh, I guess it's because I don't have a full screen descriptor or something. Or is it because there's more than one buffer? DXGI swap chain full screen descriptor. Full descriptor. I don't know. I'll give it a meaningless name. Windowed is true. Ah. Address full descript. Say that it is windowed. Still failed to get the back buffer. So swap chain is valid, but get buffer is failing for some reason. Oh, it's one of those where you have to. None. Alpha mode. Unspecified. Let's try it now. Maybe now it'll work. Now we're going to run into another problem because I don't use this one that often. Well, I have used it before, but it's just annoying. HR is even failing, so it's not even getting there. So swap effect. Flip sequential. Still not creating. What the hell? Oh, you know what? I'm an idiot, by the way. We can use standard swap chain now, I guess, because now I've got it working. But I just wrote all the code to update it, and now I'm stuck again. That's fine. Okay, so now it's actually creating, but the back buffer's doing weird stuff. Let's get buffer one and just see what happens. I think buffer one is the back buffer now. No, is it because it's protected? There's something off about this. What is this? That's no pointer. Oh, restrict output. Yeah, we don't care about that. Swap chain, full screen. That one's good. And actually, refresh rate can go away. Yeah, refresh rate is good. Flip this card. Um, width, height, swap effects, flip this card, scaling. Let's get rid of these again. Oh no, 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 no. Please no, please no, please no. I knew that this should have worked and it's not working. I'm just gonna guess. I'm just gonna guess what's going on. Inline, Microsoft, WRL, COM, pointer, ID, 3D, 11, texture, 2D, get back buffer from swap chain. And now I'm having to create global stuff because it's the only way to do this. Hold on. I'm gonna at this point YOLO, you know? Like what the hell? Okay, now we're gonna go back to the render contact. Oh no, let's see, render target. Should have been one. There you go. Alright, now let's see what happens. If this works, I swear to God, I'm gonna lose my shit. Oh, I need H result here. Oh man, I'm also sick. You guys have to forgive me. I swear to God. Look, now it works. It's so stupid. So there are certain things that are process specific, and if it's in a module, I guess it's loading in a or thinks it's in a separate process. I don't know. But anyway, now it's running and everything is working fine. So now we have a way to get a back buffer, but we have this ugly code here. Like these and where's it at? These helper. So it probably would be best to do a .h and a .cpp. I may end up doing that towards the end of the project, but all this is ridiculous. That I even have to write this code when it's already written in a simpler way inside of a class. It's just absolutely ridiculous. Where's my main at? But we have a black window and then a white window, and that's because there's nothing there. So now, before we present, we're going to clear the render target now that we've hacked our way around the module system. So we take our context which is going to have a better name eventually. Get D3D11 device context. Clear render target view. Now we need the render target view, so this is going to be render target dot get render target view. And the color is going to be DirectX colors. This is from the DirectX colors header that we included. Cornflower blue. And that should, in theory, clear the swap chain. And now we should have this blue color. Okay. Oh my goodness, bro. This was amazingly too difficult because I've never had this kind of problem. But fair warning, modules are not ready for direct 3D development. I just learned that. I figured it would be easier to kind of organize things a little better in modules, but this I've had to create a little hack to get certain functionality, specifically getting the back buffer and getting the parent to the adapter to get the factory. Those two things, for some reason, cannot be done inside of a module. They must be done inside of a CPP file. I have a feeling that there's some weird magic voodoo stuff going on in the background, and the modules are being loaded up somehow or another, probably as like onboard DLLs or something, so they're like a separate process. I don't know what's going on because I didn't look into modules on Windows or anything before I started this project. But fair warning, if you're going to do anything with modules, you need to make sure that your API is fully compatible because, as we just saw, I had to write some ugly code here in order to get my application to work correctly. But we're there. We're there. Another option is to create the render context, which can have this get back buffer from swap chain method in it, and we can just make it a standard C++ class and just put anything that's like process specific or threading specific for Direct3D that could go into that class, which is a .h and .cpp file. And then you would just have to include it. You could possibly just include it here, like in your precompiled header. But then you get circular dependency. It's all sorts of weird stuff. But anyway, I'm glad we figured it out. Thank you all for hanging in there with me. Now that we've got Direct3D initialized and we have a render target, next thing we're going to go ahead and do is when the window resizes, we need to call that onWindowResize function for our render target. And so the only way to do this is where is our window? We're going to import the 3D window render target inside of our window. We are going to do this inside of our window. This is the easiest way to do this. So go ahead and import that there. And then here, we need to create a window render target, and better yet, we'll make it a unique pointer. And now we have a render target. And so in the protected part of the window, and then again, you can just make it public if you absolutely desire it to be public. But we're going to do a D3D11 render target view. Well, get render target. All right. Why is this so difficult? All right, so now we have a render target. And here, whenever the window gets created, after it's been created, render target equals make unique D3D11 window render target. And what we need is we need pointer this because we need the window. and we need a render context. So we're gonna pass in our render context, and we're gonna make the windows take those in. So we'll have another. So import remote desk D3D11 render context. I think that was it anyway. Yeah, that's it. All right. And we need to also do the move constructors for these, but we'll do those in a minute. So every window needs a D3D11 render context. Make that const render context. And we could just make this equal get D3D11 render context like that again. And then we'll throw a invalid argument. Render context must not be null. And then we're setting it. And so that's that. Now, when we're here, we can simply just copy it. So m render context equals window.m render context. And then m what was it? Render target equals move window.m render target. And that takes care of all that. And in this one, we're exchanging that. M render context equals HG exchange window dot, well, it should invalidate it, so it shouldn't matter. Window.m render context m render target equals move m render window.m render target. Okay. And then here we're just creating our render target. And this one's weird. But anyway. So unique pointer. Identifier render target is undefined, but that's not true. It is well defined, and it's well defined right here. Make sure it's what it's called. D3D11 window render target. Okay, yeah, it's having that weird bug thing again. So every window now needs a render context to be passed into it. So we can now go to our selection window, and we can get an ID D3D11 render context. And now we don't even have to check it because we're passing it in. So this just saves us some code, although you probably really should check it. Import remote desk.d3d11 render context. Window render context, done. Okay, so now we'll go back to win main. The render target goes away. We'll call this render context. And then we're going to have our own window function called run. And it's just going to return an int. So we'll come back to our window. Virtual int run. And we'll just pure it. So that way you have to override it. And each window can possibly run a little differently. So we just have a int run override. While message.message does not equal wm quit. If peak message is message, we'll remove it from the queue. We'll translate the message and then dispatch the message. So we'll get the render context and the render target. Render context, get D3D11 device context. Clear render target view. And the first argument is render target dot get render target view. And then we have direct X colors, cornflower blue. And finally, render context dot target present. Now let's see what happens when we come back to win main. We can now get rid of all this. We now have a selection window, and we'll do win int result equals window dot run. And then inside of my selection window, when we're done, simply return static cast int message.wparam. Then we have an easy way to run. Error. Oh, wait, what? It's because the render context relies on the window. Oh. No, it's because the render target, I believe. So we could, instead of passing in a window, we could just do window. Because there is a cyclic dependency between them. Window depends on render target, and I guess render target depends on window, so we can get rid of the need for it to even process window. Okay, so now we go back to window, and we're using pointer this to create it. So instead of pointer this, M handle. Boom. Done. Remote desk run override did not override any base class methods, and that's because I'm an idiot. What failed now? Oh, where's that? Window 2, it needs the render context as well. Alright, so there's one. Let's make sure we're getting down here. Window.run should close this. Okay, it does. Result is 0. So now it should now create a second window with another render target, and it does, and another render context should just be inherited. Oh. Yeah, I forgot to show it. The second one should not, it should be black, I believe. Or maybe white, because we're not physically clearing anything. Yeah, there it goes. All right, so that's that. And then the way that we do this short term now that we have a second window, we can now do result equal window2 dot run. And now we can run the second window, we get the same result. So now we have two with render targets in them. Oh my goodness, it feels so good. We've also made this a little easier with the window.run method. So one last thing we're going to do before we exit for tonight. I think it might be worth going ahead and updating it to where the resize mechanism works by default. So we have this default window procedure here. And I want to switch on message. And we're going to do what we were doing before. Except this time we want to return L result 0. At the bottom, default, do default window procedure. And this one, WM destroy, post quit message 0. And actually I'm going to change that to exit success. Case WM size. Now what we want to do, we know that we need to resize our render target, right? So we're just going to do M render target on window resized. That part's done. But before we call that, we need to unbind it and then rebind it, right? So what we're going to do is we're going to set our render context, get device context, set render targets 0, 0, 0. And let's use C++. So let's use no pointer here because they are technically pointers. So now that should unset them. And once the window is resized, we can re-get the device context, and then we can reset our render target. So there's going to be one render target, and it's going to be render target get render target view. And we have no depth stencil buffer as of now. And I'm wondering if I could pack this like this to turn this into an array. No. Alright, let's wrap this in braces in. ID 3D11 render target view, pointer, render targets. And we'll get the render target view here. And we'll pass in our render targets. Array size render targets. All right, so now when the window changes size, it should, in theory, it should resize the back buffer. So let's go ahead and test this. No sampler, no vertex. Cool. So it looks like now it's actually calling the onResize method. And there's no real way to tell, but one thing we can do is we could set the title. So I'm going to come to my render target, include string stream, and here on window resize, actually static int num resizes. And then set window text A, and we'll set our output debug string. Yeah, let's do that instead of setting the window text. We'll output debug string. That way we can actually see what's going on. That's the string. All right, now every time we resize, we should see a number. See, now it says 0. But as we go up, you see now it's 0, 0, 0, and that's because we are actively resizing. And this one is the same. So now you can see we have shared behavior in the same windows. We'll get rid of all of this. And everything is resizing correctly. We're not getting any errors or any warnings. So we can come back. And also notice how easy this is. We just call create inside of the constructor for our window. And it will create the window. And then all you need to do is take in a render context. So you can do whatever checking you want. But if you don't check it, you pass it to the window. If render target is null or null pointer, right? Exactly what happens? Well, window throws an exception that gets trickled up to the selection window. Again, this is in release. In debug, it's gonna stop execution, but in release, it's gonna happen. Oh, what is this? Ref count 25. Oh, something else is going on. Hold on. Let's go back and try this again. That's Alienware stuff, it looks like. And then whenever we close, no, everything looks good. All the threads are exiting right. I don't know what the hell that was. Let's see. Resize, nothing, close, resize, close. You know what we're going to do whenever the window gets resized? We're going to actually get D3D11 device context clear state. I'm pretty sure that right there will help. I'm an idiot. I'm in the wrong spot. I'll go back to window. So right here, where we're setting our render targets to nothing, it may just go ahead and be worth clearing the entire state. Live object at ref count 0. What the hell is going on? I don't think this is that big of a deal, but this one says ref count 25. What the hell could be making that? Let's go to the render target. It may be resized. No, I don't think it's resized buffers. Hold on. I did find something weird. Yeah, see, I'm just using it though. I'm not. I shouldn't. Should I keep reference to this? Yeah. See, this is why I hate this. And I'll do the same thing here. Okay, and then when we come to our render target, when we're doing this, we can now just pass in the swap chain. And then when we go to our... This is a lot of work for something this simple. Again, it's because we're using modules. I wouldn't have any of these problems if it weren't for modules. We'll use the DXGI adapter. So we can come back to the precompile header. And we can actually make these references. And then if you give me a reference, everything works fine. Which a reference, I think it has to be a valid object. And maybe that got rid of it. Yeah, no warning. I close it. And then when I resize, now we have this info destroy vertex shader. Why would I destroy it? I don't understand what's going on. Is it the shaders that's the problem? Hold on. So we're going to assume that each window is only active for its time. And in the destroy, I want to clear the state if it's a valid render target. So we'll come back to our window. On destroy, we'll wrap this as well. If m render target. So if not, we'll break. And then here, we'll go ahead and post a quit message. And then if not, m render target break. And then we'll do our m render context, get device context, clear state. And this way, there's nothing tied. So whatever the window has, the state automatically gets clear when the window is destroyed. Or if it gets resized. So on size, we're going to clear the state, Oh, there's an easy workaround for this too. Just have a protected function. Virtual void on resized. And by default it does nothing, but it's a hook into. And then at the bottom here, this on resized. Boom. That takes care of that. Now I want to make sure that I am indeed using com pointers here. I am. And I am. Okay. So everything should be fine now. Yeah, I don't know what that is. That's definitely something else that's going on. So it's nothing in my code, I don't think. So I think we're good. This is still weird. I still can't get beyond this. So now in the selection window, right? Every frame, we're clearing the render target view, but we don't actually have to do that. We only really have to do it after creation. So I'll show you. So we'll do this after we create and on resize. I know. On resized. And then we only need to get the render target. We no longer need the context. And by default, it will set, the default window will set up everything. Render context is good. And this is just as an example. And as soon as you create the render target and all that, whoa! Oh, it's because there's two back buffers. That's actually, whoa, that's trippy. Don't look at that. I forgot it's because there's two back buffers. So if we come here, change this to 1, see if it still compiles. Okay, so that doesn't compile. We need 2, and let's change it to sequential. One of these, it's supposed to swap the current back buffer, and I think it might be all of them, but I'm not clearing every frame, so that's why we're getting that effect, but it is what it is. So yeah, we do need to clear every frame. Let's see what else. Yeah, that's something like if you were to use the standard swap chain, that is something that you can do. Is you only have to set it up once, but you can see there's two buffers. There's a black one, and if I can catch it, yeah. So there's a an all black buffer, and then there's this blue buffer. It is flashing in between the two. But yeah, so this is our code now. I'm going to get rid of all this. I'm going to get rid of this. The next thing is direct 2D, and we'll probably do that in the next video. Let's go ahead and fix this. Boom. Everything looks good now. And then the only thing we want to do in present, there's one more thing. We want to default it to sync. So present, we want it to default to every vertical sync point, every synchronization interval, if you will. And boom. Next thing, direct 2D. And we're on to making our UI for the selection window, which is just going to basically be two buttons and a cool little title. It's basically going to be like a splash screen. We can also get rid of the resize thing, just have it kind of pop up, and we can just have the options there and say, are you admin? And again, this application is not going to look very pretty, okay? Just a heads up on that. I am by no means a designer, but we are going to do our best to make all of this stuff work. Sorry, I know this is like a 2 hour long video, but there's a lot of bugs. There was a lot of me trying to research what's going on, and the next video will be up probably in the next week or two. But again, I work 3 jobs, so it's hard for me to schedule out content like this. Um, but the DirectX part is looking pretty good now. Now we've got a render context and we've got render targets that we're now rendering into. And it took a lot more work than it should have, specifically because it would not let us render, or it would not even let us get to render because of the weird module thing. And I'm probably going to put in a ticket for this because that code should have worked and it did not work. It's something weird with modules. So I'll probably put in a bug report on C++ modules in Visual Studio for this specifically. But anyway, you guys, y'all take care. I'll see y'all next video.